Mediterranean ancestry. Mediterranean ancestry emerges along coastlines where sunlight is abundant, seasons are gentle, and life grew around orchards, vineyards, and the sea. Here, generations carried forward an olive-toned complexion, moderate melanin that softens the sun's intensity while still inviting steady vitamin D synthesis. This balance is one of the region's signature advantages, a skin biology tuned for bright days without the fragility of easy burning. Within the body, subtler protections appear. A long heritage of consuming olives, fish, grapes, and herbs didn't simply shape culture. It shaped metabolism itself. Genes influencing lipid processing, including those tied to the PO1 enzyme, respond strongly to monounsaturated fats, guarding blood vessels from oxidative damage. Combined with diets rich in antioxidants, this created a physiology that leans toward higher HDL, lower inflammation, and durable cardiovascular health. Evolution favored those who thrived in sun-drenched agriculture, bodies that store fat more safely beneath the skin, bones fortified by daily light, and metabolisms comfortable with energy-dense oils. Its trade-offs remain familiar. Moderate melanin can still permit sun damage, and lactose intolerance is historically common. Studies show lactose intolerance rates can go up to 75% in specific Greeks and 78% in Lebanese adults. Yet the deeper story is harmony, biology shaped by coastal light, fertile soil, and the quiet medicine of traditional foods. Khoisan ancestry. Khoisan ancestry represents one of humanity's oldest and most versatile genetic lineages, a reservoir of diversity that has endured in southern Africa for tens of thousands of years. Instead of evolving around a single dramatic mutation, the Khoisan retained an extraordinary breadth of genetic variation, giving their populations a wide biological toolkit for survival. This diversity acts as a natural buffer. When climates shift, foods change, or diseases emerge, some individuals almost always possess alleles suited to the new challenge. In ancient foraging societies, this meant metabolic flexibility, variable immune strengths, and adaptive physical traits that collectively promoted stability in the face of drought, feast and famine cycles, and environmental extremes. Functionally, Khoisan physiology reflects this broad adaptability. Efficient kidney concentration supports life in semi-desert landscapes. Distinctive fat storage patterns help buffer against seasonal scarcity, and rapid metabolic shifts allow effective use of both lean periods and abundance. Even their calm, measured stress responses mirror a biology refined by the demands of long hunts and unpredictable environments. But diversity, too, comes with challenges. Lack of historic exposure to outside pathogens left some Khoisan groups vulnerable to introduced diseases like smallpox, and highly individualized genomes can complicate standardized medical treatments, challenges that sharpen when traditional lifestyles give way to rapid modern change. But Khoisan ancestry stands as a living archive of humanity's earliest adaptability, proof that genetic breadth itself can be an enduring advantage. Amazonian ancestry. Amazonian ancestry reflects a physiology shaped by one of the most pathogen-dense environments on Earth. In the rainforests of Brazil, Peru, Colombia, Bolivia, and Venezuela, indigenous communities evolved immune systems finely tuned to confront parasites, fungi, insects, and vector-borne diseases that once overwhelmed outsiders. High frequencies of specialized HLA alleles enhance recognition of tropical parasites, while rare variants in genes such as PPP3CA strengthen T-cell activation and even reduce the ability of Chagas-causing parasites to invade the heart. At the same time, adaptations in innate immune receptors dampen excessive inflammation, allowing strong microbial defense without the damaging overreaction typical of chronic infection. The result is an immune system that balances vigilance with restraint, an elegant solution to constant microbial pressure. These advantages manifest in elevated baseline antibodies, efficient parasite clearance, and remarkable recovery from repeated infections. Enlarged spleens, controlled inflammation, and metabolic strategies that protect growth during illness reflect the rainforest's evolutionary demands. But specialization can carry modern vulnerabilities. Hyperactive immune wiring can misfire in cleaner urban environments, increasing risks of allergies, asthma, or metabolic imbalance, and certain adaptations remain highly specific, offering little defense against novel pathogens. These challenges sharpen when Amazonian physiology leaves the ecological context that shaped it. Amazonian ancestry stands as a profound example of pathogen-forged resilience, bodies and immune systems trained by the relentless pulse of the rainforest.